Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 279, perfect squares. Given an integer n, return the least number of perfect square numbers that sum to n. Okay, a perfect square is an integer that is square of an integer. In other words, it is the product of some integer with itself. For example, 1 comma 4 comma 9 comma 16. So these are the perfect squares, right? Because 1 square is 1, 2 square is 4, and 3 square is 9, and 4 square is 16. Meanwhile 25 is also a perfect square. Okay, and while 3 and 11 are not perfect square, okay, as you know already. Fine. So see here, if n is equal to 12, then they have given that the minimum value we will be taking is 444. All are perfect squares because these can be gained by the 2 square. If I multiply 2 by itself, then I'll be getting the 4, right? So 4 is a perfect square. So if I add 3 fours, then the answer, the result will be at 12. Okay, so that's the reason why they have given the output as 3. Okay, similarly for this 12, I can also take like if I take 9 plus 1 plus 1 plus 1, so this is equal to 12 only, right? So I can either take like this also, but here how many numbers I have taken? I have taken 4 numbers. Okay, whereas in previous example, the 4 plus 4 plus 4, there are only of 3 numbers. So which is minimum? 3 is minimum. That's the reason why we are taking the 3. Okay, so here clearly we have seen the problem, right? Now from this problem, I can easily tell you we are going to use the all combination method, which means we are going to use the recursion and backtracking, right? So if you haven't saw my recursion video, go and just see that recursion introduction video and just observe how the recursion works, what is meant by recursion tree, and what is meant by recursion stack. Then continue this video. Okay, unless or until that, just don't continue this video because you cannot understand the recursion tree. Okay, I will be giving that video link in the description. Fine. Now, whenever we are going to design a recursion, first we want to design the function, right? So what are the parameters going to be affecting my function? So if they have given 12 as the input, then I want to check how far I can take some elements. Okay, so obviously I only take 1, 4 and 9. Apart from that, I cannot take any other perfect squares, right? I cannot take a perfect square called 16 because 16 is greater than 12. 16 is greater than 12. So where I am starting this? So I am going to start from 3. So 3 square is 9. 2 square is 4. 1 square is 1. So I am going to start from 3. Okay. And what is my initial value? It is 12. So this is going to be your parameter. So what is going to be your parameter? The parameter is actually going to be like what is the number, or what is a perfect square number. Okay, that is going to the first parameter. Meanwhile, the second parameter is actually given n value, this n value. Okay, now how I am going to split this recursion, because remember many of them are just misunderstanding that recursion is some kind of a process. Not it is exactly like a process, but recursion is like we have a big problem. We are going to divide it into a sub problem such a way that we cannot further divide that sub problem into any other sub problem. We can directly find out the solution there. Then by using all the solutions, we are going to build a main solution for the main problem. Okay, so that's the formal definition of recursion also. So from that, always whenever you are writing a recursion, always it's your thing to break the main problem into a sub problem. So how we are going to break the main problem into a sub problem? So from here I can break into two types. One is either I can take this 3 or I don't want to take this 3, right? Can I understand this? So what is the 3 square? This 9. So I can either take this 9 or I don't take this 9 and go to the 4, which means 2 square. Can you understand this? Yes. So this problem is much more tricky if you haven't solved much recursion questions before. Okay, that's the reason why I told you want to go and watch my recursion introduction video, and maximum just go and watch my all the recursion videos in my recursion playlist, because that will be very much useful in this video. Okay, fine. So if I take this 3, what is my recursion call? It will be like, hey, you have taken the 3, so I want to check what is the 3 square? It is 9. Whether 9 is less than or equal to 12. Yes, then you can take it, right? You can take it. If I take it, hey, don't go anywhere else. Stand there itself. Stand there itself, which means standard 3 itself. But reduce my 9 from the 12. If I reduce the 9 from 12, it will be something like 3. So it will be 3, 3. And then we have taken the 9 as one of the value, right? So put 1 plus. Okay. So if I don't take it, it will be like 2, 12. Simple. I don't take it. I just gone to the next value. So my given n is not affected anyways, right? Okay. Now the next step. Here also I can either take or not take, right? But here whether I can take it or not. No, I cannot take it because 9 is less than or equal to 3. No. So I cannot take it. So whenever you cannot take it, return infinity. Why I am returning infinity? You may ask, because in the question they are asking the minimum. So however, we are going to take the minimum among the recursion calls. So whether infinity is a minimum or a maximum, it is a maximum. That's the reason why I am returning it. Understand this? Okay. Similarly here, if I don't take it, it will be something like 2, 3. Yes. Similarly here, if I take it, it will be 1 plus f of 2, 8, because 12 minus 4, which is equal to 8. If I don't take it, it will be f of 1, 12, right? Now here, whether I can take it? No, I cannot take it. So I will be returning infinity, because 4 is not less than or equal to 3. That's the reason why. So I go for not pick. So if I don't pick, it will be something like 1, 3. Okay. Similarly here, I can either take it, because 4 is less than or equal to 8. So I can take it. So 1 plus f of 2, 4 minus 4, which is equal to 4. Okay. Similarly here, I don't want to take it. If I don't take it, it will be f of 1, 8. Okay. Similarly, just try to understand. I cannot write this entirely down. Okay. So here, what it will be splitting. Here alone I will be telling. Apart from that, you want to try this recursion tree. Okay. So here it will be like either I can take it, because 1 square is 1. 1 is less than or equal to this 12, right? So if I take it, it will be something like 1, 11. Okay. If I don't take it, it will be something like f of 0, 12. Whether 0 square is any valid form. No. 0 square will be again yielding what? 0 only. So from this I can tell you, whenever we reach the number here is 0, I want to return infinity, because it is not a valid thing. That's the reason why I am returning the infinity. Okay, fine. Now here at this particular point, follow my red color. So here at this particular point, observe this carefully. Again it will be splitting like what? Again it will be splitting like 1 plus f of 1, 10. And then here it will be again returning infinity, because this value will be 0. Okay. So this will be going on to the last for 10 times, because 10 will be reduced by 1 for 10 times to reach this 10 to 0. Okay. So this part you want to try. Okay. I cannot write that. It will be taking much more time. Okay. So see here. Here again I can take it. So if I take it, it will be f of 1 plus f of 1, 2. If I don't take it, it will be 0, 3. So again it will be returning infinity. Again if I take it, it will be 1 plus f of 1, 1. If I don't take it, it will be f of 0, 2. So it will be returning infinity, right? Again if I take it, it will be 1 plus f of 1, 0. Now I want you to understand this clearly. Okay, what is this? It is f of 1, 0, which means our target value is satisfied. Whenever our target value is satisfied, just return 0. So 1 plus 0 will be 1. Can I understand this? Okay. So what is the next recursion call? It will be something like f of 1, 0. Okay. Sorry, 0, 1. So here I will be returning infinity. Now tell me whether 1 or infinity, which is lesser. 1 is minimum. 1 is minimum. So this entire function will be replaced as 1. So 1 plus 1 will be 2. Now 2 or infinity, which is minimum. 2 is minimum. So 1 plus 2, which is equal to 3. Now 3 or infinity, which is minimum. 3 is minimum. So this will be returning me 3. Now 3 or infinity, which is minimum. 3 is minimum. So this will be returning me 3. Now 3 or infinity, which is minimum. 3. So substitute here. 1 plus 3, which is equal to 4. 4. Can you understand this? Can you understand this? Similarly, let us finish here also. Again, this will be like 1 plus f of 2 comma 4 minus 4, which is equal to 0, or else I don't want to take it. If I don't want to take it, it will be going for f of 1 comma 4. Whenever it is f of 1 comma 4, we already computed here, right? So it will be again and again going for 4 times. Okay, here it will be again and again going for 8 times. Here it will be again and going for 4 times, and here it will be again and again going for 12 times. Can you understand this? Can you understand this? So anyhow, we will be getting a value up to here. Okay, sorry, you want to complete this entire recursion tree. Okay, that's my wish. Okay, fine. So see here it is 1 plus 0, which is equal to 1. So this function will be replaced as 1. So 1 plus 1 is equal to 2. So here and here it will be 4. That's the reason why I am not taking this. Can I understand this? Because here it is returning 1 and here it is 4, which is minimum. 1 is minimum. Here it is 8. Okay, but here it is 2, which is minimum. 2 is minimum. That's the reason I am taking 2 only. 1 plus 2, which is equal to 3. This is equal to 3. But here it is f of 12. F of 1 comma 12 means it will be going up to 12 times. Okay. Now 3 or 12, which is minimum. 3 is minimum. I will be passing out the 3. So you want to finish this recursion tree to understand this. Okay. Now 4 or 3, which is minimum. 3 is minimum. So I will be returning the 3 as my output. Can you understand this? Can you understand this? So many of them will be doing a mistake. On the splitting the recursion calls, and also which I want to return back. Okay, so this is what the entire recursion tree, and tell me what is the time complexity going to be. So time complexity will be over. See here, every time I am splitting into 2 types, so it will be 2 power for every recursion calls I am splitting into 2. So 2 power. How many times I am going to split? So I am going to split this 12, which means the given n into again I am how many times going on? It will be perfect square times, which means root n. So it will be 2 power n root n as my time complexity, and space complexity will be over n root n. That's it. So this is going to be a time and space complexity analysis for this particular recursion approach. Okay, so let us see that code. Here I have given the Java code. If you want the C++ or Python code, just go and search in the description. Okay. So what is the first step? First step is I want to find how much time, how long I want to take the range, right? So I just taken the nums as 1. Okay, and I'm just checking whether the perfect square is less than or equal to the given n. If it is so, I want to do a nums plus plus. If it is not, I will be terminating from the looping, right? Now at last return the helper function of nums minus 1 comma n, because if the given value is 12, then the nums value will be 4. But 4 square is 16, but 16 is not lesser than or equal to 12. That's the reason why I'm doing here as nums minus 1. Okay, which means when nums is 4, it will be giving you only 3. You want to start from 3. That's the reason I'm giving here as nums minus 1. Just try to understand this. Okay. Now here, what are the 2 base conditions I want to do? So one of the base condition is if my n is equal to 0, which means my target is attained. At that particular time, I will be returning 0. If not, maybe the number which is meant for the perfect square reaches the 0. At that particular time, I want to return the infinity. Okay, and I have 2 choices. One choice is I can take it. If I take it, I want to satisfy this condition. What is the condition? The target should be strictly greater than or equal to the square of the I. If it is so, then I can take it. How I will be taking it? 1 plus recursion call of I comma n minus the square of I. N minus the square of I. Can you understand this? Similarly, if I not take it, it will be something like hey, just go to the next value and don't do anything in the target value. Okay, at last what should I return? I will be returning the minimum amount. That's it. Understand this? So this is going to be your entire recursion code. If you submit it, it will be not submitted successfully. So the time complexity is huge. That's the reason why we are just next going into the optimization technique called memoization. So as a recap, I will be giving you what is memoization. Memoization means we will be storing something in my memory in case it occurs again. Instead of go and finding it again, I'll be just directly pulling out from the memory. Okay, so that's the use of memoization. So memoization can be done using hash map and also array. So I highly recommend you to know about the array, because hash map is going to be very easy, and I want you to understand this array concept. I will be teaching you this array and implement this hash map by yourself, because it is so simple hash map. Okay, fine. So see here, for example, okay, here it is f of 3, 3, right? In case, in some other case, in some other recursion tree, there will be again f of 3, 3. Okay, that is again occurrence of f of 3, 3. Okay, then I want to again go for these all recursion calls, right? These all recursion calls to find out what is the value of 3, 3. If I already just saved this in my memory, somewhere in my memory, then when I came to this particular f of 3, 3, then instead of going to all the recursion calls, I'll be just pulling out from the memory itself instead of going for the all the recursion calls. This will be much more time efficient, right? So for this only we are going to use the memoization technique using the array. Okay, so here we want to just follow some set of rules. The first set of rules is we want to find the dimension of the array. So see here, what are the varying parameters here? There are two varying parameters. One is I and another one is n. Both are varying, right? So from this I can declare it is a 2D array, a matrix. Okay. Now what is going to size of this matrix? The next thing. Okay. If they have given here like n will be from where to where, 0 up to where, up to n. Okay. Okay. And what is my I value? I value will be from 0, okay, up to where, up to nums minus 1. So from this I can tell you we will be taking nums and n plus 1 as a dimension. Nums cross n plus 1 as my array dimension. Can you understand this? Yes. For example, if the given n value is 5, the given n value is 5, then what is going to be my nums? My nums is going to be 2. My nums is going to be 2 because 2 square will be equal to this 5. Can you understand this? In short term, let us take the 12 itself. Okay, because 12 we have already saw, right? So for 12, what is my nums value? My nums is equal to 3. 4. We have already saw that. Okay, and what is my n value? It is 12. So according to my dimensions, what should I take? I should be taking 4 rows and 12 columns. Can you understand this? So this is going to be your overall dimension. Okay. Then what is the next step is I want to decide what is going to be the dimension. What is going to be the initial value of this particular thing. Okay. So here it will be of 13 columns, because n plus 1, right? N plus 1 columns. Nums as a row and n plus 1 as a column. And then everything will be filled as minus 1. You may ask, hey, why we are filling as minus 1? Because always whenever we are initializing some values in the memoization array, just go and watch what are the values that are returning from the function. So here it is returning 3, here it is returning 0, here it is returning 1 and 4 and something 8 or infinity, like that. So what are the elements that are not returning? They are not returning minus 1, they are not returning minus 2, they are not returning minus 3. So negative values are not returning, right? So that's the reason why I am putting as minus 1. If you want, you will be initializing all the values as minus 2 or minus 3. That's your wish. Okay. Here, as of now, I am just initializing as minus 1. Now, hope you understand what is going to be the memoization array. Now, we want to do some more additional code to make this into a memoization technique. So after the base condition, I want to add one more base condition, like if, take for example, it is a DP array, DP matrix. Okay, if my DP of I and n is not equal to -1, then what should I return? I will be returning that answer itself. You cannot understand why I am putting like this. Now, instead of this return statement, first I want to update it, then I want to return it. I want to update the minimum among pick and not pick. Then in next line, I'll be just returning the DP of I and n. Now you can understand this clearly, right? So here what I'm doing, here I'm updating it. Here what I'm doing, here I'm just checking whether it is computed already. If it is computed already, then don't worry, just return it. Okay, don't go for the again a recursion call. Don't go for the body of the recursion call. Just in the base condition itself, return it. So by doing these steps, I can tell you the time complexity will be reduced to n into square root of n, and space complexity will be reduced to n square root of n. Sorry, space complexity will be remain same, but time complexity will be reduced. Okay, and then the space complexity is because of two types now. Okay, this is going to be a new problem. So one is because of the recursion stack, as you know. Another one is because of the memoization matrix we have used. Okay, now our job in future is to optimize the space also. Fine. Before that, let us see the code, then we can return back. So see here, this is going to be your memoization code. Okay. Now, the first step I have told you, right? We want to find the dimension of the matrix. So what is the dimension of the matrix? It is the varying parameter. And what is the varying parameter value? It will be from 0 up to nums minus 1. Meanwhile, for n, it will be from 0 up to n. That's the reason I am putting n plus 1. Because n is also included. So we want that particular index also. That's the reason I am putting n plus 1. Can you understand this? Okay. Now, I'm just initializing all the values as -1. Okay. Now, then here, that's a one step I want to add. Again, here I want to add another step. That's it. Simple, right? So by doing this, I can tell you my time is hugely reduced. Okay, so this technique is called memoization technique, and I want you to implement the memoization using HashMap. Okay, because memoization using HashMap is much easier, and it also have its own disadvantages. Okay, but when you want to use the memoization technique for a fast manner, then you can use the HashMap instead of going for the array, because array will be like you will be always making some mistakes there. Okay, fine. Now the next step, the next optimization technique is tabulation. So what is meant by tabulation? So see here our space is because of, one is because of our matrix, but another one is because of our recursion stack. Now we want to eliminate this recursion stack. To eliminate the recursion stack, we don't want to use the recursion. So if I don't want to use the recursion, then I want to go for a looping, obviously. Okay. Now here also you want to follow some more steps to convert the memoization code into a tabulation code. So what are they? So see here, listen this carefully. It is quite similar to the memoization, but it is pretty much harder than it. Okay. So first thing is we want to check whether we want to alter this given this memoization array or not. So see here, to alter the memoization array, the DP array, I want to check the base condition. So what is the base condition? It is n is equal to 0, right? So for example, let me write here so that you can understand. So for example, n is equal to 12. Then what is my nums? My nums is equal to 4, right? My nums is equal to 4. And also what is my dimension? It will be nums cross n plus 1, right? Now with this help, then let me draw the matrix. So here it will be 4 rows, which means 0, 1, 2 and 3, and here it will be 13 columns. So 0, 1, 2 going up to where? Up to 12. Okay. So this is what my matrix looks like. Now observe this carefully. Everything is filled with -1 in terms of the memoization. So we can eliminate this. We can eliminate these lines because we don't want that particular value of that particular cell. So see here in the body we didn't took any values at that particular value for the computing. Like if I want to compute the ith row and jth column, then I don't want to know about the ith row and the jth column. I just want to know some other rows and some other columns. That's the reason why we don't want to initialize everything as -1. Observe that carefully. Okay. Now, what they have given here, if n is equal to 0, then what I want to return? I want to return 0. Okay. Okay. So, what is meant by n is equal to 0? First of all, here, which means n, the column. Okay. So, whenever the column is 0, I want to return 0. Whenever the column is 0, I want to return 0. So here 0, 0, 0, everything will be 0. Can I understand this? So sorry. The zeroth column should be 0. So 0, 0, 0 and 0. Everything will be 0. Can I understand this? Okay. What is another base condition? This, if my I is equal to 0, which means my row is 0, then I want to make everything as infinity. Okay. Okay. So make everything as infinity. That's fine. But whether this particular value should be 0 or infinity, that's the next doubt we will be arising, right? So let me take an example. It is 0, 0, f of 0, 0. Whether you will be returning infinity or 0, you will be returning 0, because anyhow my target is 0. Then I don't want to worry about it, right? So that's the reason why I'll be leaving this as it is, like 0 itself. So understand this 0, 0. This particular index should be 0. It should not be infinity. Okay. So these are the changes I want to do in the matrix. Okay. What's the next change? So next thing, I want to remove this base condition. Rest of these values are what? Are body of my recursion. So whenever I attained or whenever I reached the body of the recursion, I want to go with the tabulation technique, which means I want to go with the looping. So go with the looping for, so first value. So here it will be like I want to go with I and n. Okay. So for taking this I and n, let me take I. So I will be starting from where to where? So it will be starting from nums -1 and ending at where? Ending at 0, which means for 0 we have a base condition. Which means I will be starting from nums -1 and I will be going up to 1 only. So reverse it. Always remember, reverse it when we are using the looping, which means I will be starting from 1 and going up to where? Going up to nums -1. Okay. Similarly for the second thing also. So the second thing, this n value, also I want to reverse it. So let me take n. Okay. So n should be where to where? So it will be starting from 1 and going up to n, which means n is included. Okay. So 1 up to n. Okay. So for this, let us take this value as m or num. That's your wish. Okay. Because here also n and here also n means it is ambiguity. That's the reason I am changing it. Fine. Okay. What's the next step? Next step, just put everything in the body here also. So what is the first line? So first line is pick is equal to int max. So infinity. Okay. Now what is the next line? If my n value, instead of n, here I have taken as m for the looping purpose, right? So m is greater than or equal to I cross I. Then what should you do? Just write that itself. So pick is equal to 1 plus here what? It is a recursion call. Whenever it is a recursion call, let's just skip that. So this array name is dp. Okay. Now dp of, so what is the varying parameter is I. So put I, and what is the next varying parameter? It is n minus I square. So instead of n, I used what? M here. So m minus I square. Can you understand this? Okay. Again, here it is not pick. So come here, not pick is equal to, again it is a recursion call. Whenever it is a recursion call, I told you put a dp of what is the varying parameter? This is I plus I minus 1 and then n. Okay. Fine. What's the next step? Just to go to the dp of in this line, dp of I and n, which is equal to what is the minimum among pick and not pick. That's it. Can you understand this? Okay. At last, after finishing all the loop, what should I return? Return what I am returning here? Here I am returning combination of nums minus 1 comma n. So whenever there's a recursion call, I want to just do what? dp of what is the varying parameter? It is nums minus 1 and another varying parameter is n. So put that here also. That's it. Simple. So these are the lines of code you want to change to make my memorization into a tabulation. Now tell me what's the time complexity? I can tell you the time complexity is same and space complexity is also same, but we have eliminated the recursion. Fine. So let me show you the code, then we can go and continue it further. So see here. So this is going to be a code. So everything is similar. The only difference is, see here, the 0th row fully should be of infinity, the int max. Meanwhile, the 0th column fully of 0. So what is the 0 comma 0 value? It also 0. That's the reason why I declare the 0. I insert a 0 after the infinity. Okay. Now what is my I value? It is from 1 up to nums minus 1. That's the reason why I am putting less than num. Similarly here, it will be starting from 1 up to n. Okay, fine. Everything rest of them is as same as I wrote there. So there I have used m, right? So here I have used sum. That's the only difference. Fine. So this is going to be your tabulation code. Let me take this tabulation code and we can still optimize it. Okay. So you may ask, hey, what you are going to still optimize it? I can optimize the space because the space is what? N into root n, right? So if I optimize it, it will become n. Okay. So what is the next step is space optimization technique. So this space optimization technique is a bit trickier than any other techniques. Okay, because here you want to do very carefully, and here many will be leading some errors and some difficulties. Okay, will be having some difficulties. Fine. So here you want to analyze whatever the matrix or whatever the space is needed, whether we are using some unnecessary space or not. Okay, so how we are going to analyze it? Go to the inner loop. Always go to the inner loop, that body. Okay, go to that and check. Here we are using what? dp of I and something. Here we are using dp of I minus 1 and something. Okay, here again I am using dp of I and some. Okay, so from here I can tell you we are only using two rows. Right? So as usual, if n is equal to 12, then I'm taking what? I'm taking 4 rows and 13 columns, right? 4 rows and 13 columns. Instead of that, I can only take 2 rows and 13 columns. Okay, you may think, hey, you are only reducing 2 rows. How the space is optimized? Let me show you. If n, take for example, if n is equal to something like 10,000, then what is its square root? Its square root is only 100. So we need 100 rows, but actually here we only need 2 rows. So it is vastly reduced from root n to constant. Can you understand this? So this is what I'm going to do now. So what I'm going to do now is I'll be taking 2 rows individually. You can also take 2 cross n plus 1 matrix, that's your wish, but I'm taking 2 different variables to store n plus 1 column. So here also n plus 1 column and here also n plus 1 column. Okay, please try to pay some attention and just please be patient because I'm going a bit slow for you to understand. Okay, fine. Now let me take this as previous, let me take this as current. Okay, so this previous is slightly demonstrating the dp of I minus 1, the previous row, and this current will be of dp of I, which is the current row. Just imagine like that. Okay, now instead of this one line, instead of this dp declaration, I have declared these two things. Okay, now the next step is I want to initialize all as an infinity, right? So here what I'm going to do is I'll be taking my previous row. I will be taking my previous row as infinity. My previous row as infinity. Okay. So these everything will be of infinity, 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 everything is infinity. Can I understand after this? Okay, okay. Now I can eliminate this and this. Okay, fine. Now coming to the for loop. Okay, put two for loop. Then what I'm going to do is in between this for loop, I'm going to just make my current of zeroth in this value as 0. Zeroth in this value as 0 because you know that we want to make the first this value as 0, right? This value is 0. So at this particular point I'll be making my current of 0 as 0, and before the loop I'll be making my previous of 0 as 0, because in tabulation we are doing that, right? Our 0th column should be remaining 0. That's the reason I am doing here also. Okay. So when I'm going for the code, you can understand this clearly. Okay, now I'm just demonstrating it. Okay, now let me take any other color. So here at this particular point, what I'm going to replace it. So it is dp of I and sum minus I square, right? So instead of dp of I, I'll be replacing as current of sum minus I square. Okay. Similarly here I'll be replacing as previous of sum. Similarly here I'll be replacing as current of sum. Can you understand this? Okay. Okay. And also after finishing all the for loops, so here the inner for loop, after finishing the inner for loop, what should I do? I will be making my previous as my current. Can I understand this? At last, what should I return? I'll be returning so current or previous, anything, because these both things will be same after the entire execution, right? So current of n, that's it. So this is going to be the entire changes to make our space optimized. Okay. Now tell me what is the time complexity? It will be O of n into square root of n, and space complexity will be O of n only, not root n. Root n is eliminated because here we are only taking 2 rows, which is a constant space. Can you understand this? Fine. So that's it for the space optimization technique. So if you cannot understand till now, let me give you some sort of logic and just try to understand this. So at first I'll be taking these two rows, whereas this will be my previous, this will be my current, and this will be my previous. Okay, and I'll be computing the values. Okay, fine. Now the next thing is I'll be going to these two rows, then I'll be computing the values. Then I'll be going to these two rows and computing the values. Instead of taking this entire matrix, I'll be only taking the 2 rows. That's the core logic behind it. Okay. Now let us see the code so that you can understand this clearly. So see here, this is going to be your code. So see here, at first my previous and current will be n plus 1 array. That's it. Okay, you can also take as dp is equal to 2 cross n plus 1 as matrix. That's your wish. So here I already told you, right? So in previous the 0th end is only 0, other all will be infinity only. That's the reason why I'm just declaring everything as infinity, and only the 0th end is as 0. Okay, and then come to here. So here I'm starting the looping as similar to the tabulation technique, but here I'll be making my current of 0 as 0, because you already know the 0th column should be 0. That's the reason I am doing this. Okay, and then these two lines, these lines are same, but here it is different, right? So here what I have done here, it is dp of I. Instead of dp of I have changed it into current. That same thing I have done here also. I changed it into current. Similarly here it is dp of I minus 1. Instead of that I just changed it into previous. Here again I changed it into current. Here at last I'll be making the current as the previous. Okay, I'll be initializing the current into the previous, so that it will be like in next iteration in next iteration, my previous will be acting like a current such that it will be indicating my previous row. It will be indicating my previous row. Can you understand this? At last, I will be returning the previous of n or current of n because both are declared globally, right? So it is not declared inside here, locally. So this is what the space automation technique, and I want you to just go and dry run for these all 4 approaches. Take some example and dry run for these all 4 approaches so that you can understand each and every approach clearly. If you really like this video, subscribe to my channel and don't skip any videos in this DP series because all DP series videos will be so much helpful. And if you have any doubts regarding this approaches, just comment below. I'll be commenting the answers in the comment section. Thank you.